Hey, welcome everyone to my channel. And today we are going to discuss the problem of the day, that is maximum level sum of a binary tree. So this is the POTD of 6th January 2026, and let's go ahead. So let's go through the question first. What does the question say? Given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on, return the smallest level x such that sum of all the values of node at level x is maximal. So, what does the question try to say to us is like, let's say we have been given a tree. Let's make a tree here. Let's make one and the same tree that was given in that example. Let's take that 0, and then we had 7, and then we have -8. Okay, so the problem says that the root of the tree, that is this node, is at level 1. This node, these nodes are at level 2, and these nodes are at level 3. Okay, level 1, level 2, and level 3. So the problem says that return the smallest level of x, the smallest level at which sum of all the nodes is maximum. Okay, so let's say we have level 1, and what are the sum of the nodes present at level 1? It's 1. Then we say level 2. What are the sum of all the nodes at level 2? It's 7 plus 0 equal to 7. Okay. What are the sum of the nodes present at level 3? Let's see, we have 7 plus -8. And the total comes out to be -1. Okay, so so these are the sums that are present at level 1, level 2, and level 3. Which level has the maximum sum right now? I find out that level 2 has maximum sum. So level 2, I find out that level 2 has the maximum sum. So as the answer, I will return level 2, because level 2 has the maximum sum, that is 7. Now the question also says one more thing, which I would like to explain you with an example again. So let's say 1, 7, just modify the above example, 7, 0, and let's say it has like 7 and a 0. This is again L1, level 1, this is again level 2, and this is again level 3. So when I see the sum of L1 is 1 again, the sum of L2 is 7 plus 0 is 7 again, the sum of L3 is 7 plus 0 and 7 again. Now both these levels have the same sum. So as the question says that we need to return the smallest level at which the sum is maximum. So we have level 2. Now this level 2 has the maximal sum, and level 2 and level 3 have the maximum sum, but level 2 is numerically smaller. The number 2 is numerically smaller than 3. So we would simply return 2 as the level. 2 as the level. Okay. Now, okay. So this is the logic of how to find the solution of this problem. But now how to implement this in code, in the form of code. Okay, so let me explain it to you. Let's take that same example again. 1, 7, 0, 7 and -8. Okay, and this is the root. Okay, so what we're gonna do, we're gonna take a variable maxsum. Since we haven't started traversing the tree, let's take the maximum sum to be int minimum right now. That's the negative maximum int minimum, and let's take the max level since we don't have any level right now, let's store it to be 0. Let's store it to be 0. Okay. So, so if you know, like when we do BFS traversal of the tree, what we use a queue. First in, first out. We use a tree. First in, first out. Okay. So if we're gonna use the BFS traversal here, the concept of BFS here, once again, okay. So let's say we make a queue data structure, queue, node star, and nodes. So in this data structure, we are going to store all the nodes. Okay, let's see, we have a queue here, and in that we have 1. We push the root node in that level. Okay. Now, when we need to like traverse the tree, what we do? We use a while loop, right? We always do a while loop while queue is not empty. So here also again we're gonna use a while loop here. We're gonna again here use a while loop. We again gonna use a while loop here. Now, let's say we have the root in the queue. Okay, so we know that the current queue storage hold all the nodes that are present at the current level. So let's say our level is 1 right now. So let's start. Let's also wait. Let's say we have, let's say we have a level as well 0. Okay, so when we start our while loop, we know that the root is at level 1. Okay, so we're gonna increment the level 1, and we're gonna see the size of the queue, because all the nodes present in the queue right now are at the same level. Okay, so we take the size of the queue. So once we get the size of the queue, what we're gonna do, since they are all at the same level, we're gonna like pop them from the queue one by one, add like, and also form a sum variable where we're gonna like store the sum of all the nodes present at the same level. Okay, so what we're gonna do, like we're gonna pop the nodes one by one at the same level, sum them up, and push the nodes at the next level in the queue so they can be processed at the next level. Okay, so let's say I have 1 in the queue. I pop this one out, and I do the current sum is 1. Okay, now that this current sum is at 1. Now, like before doing that, one more thing that I would like to tell, like inside the while loop, since all these nodes that are present right now in the queue are at the same level, so we would run a for loop for int I equal to 0 till I less than size I plus plus, and we're gonna like keep on popping in this loop so that we can process all the nodes at the same level together, and can push the next nodes subsequent next nodes at the subsequent level in the queue. What if we don't use this for loop? Then we would never know that how many nodes are present at this level, and we will like keep on pushing and popping, and we would never able to like get that distinction of the levels here. Okay, so as we pop node 1 here, we find that the sum at the current level is 1, which is greater than the maximum. So we update the maximum to 1, and also what we do, we also update the max level. We update the max level as 1, because this is the level at which we found the maximum sum, that is 1. Okay, now we push the left and right nodes of 1 if they're present in the queue. So they're like, I push 7, I push 0 in the queue. Okay, now this loop is over because the size of this loop was only 1. So now I again check the size of q, and now it's 2. Now this loop run like twice, so this size become twice here. And for the first time I pop 7. I pops like 7. It's a q, it's a q, so consider it like that, first in first out. So I pop 7. Now I know that I'll again make the sum 0 because I'm doing it for a new level. Now I add 7 to it. Okay, now then I add left and right of 7 inside the queue. So I add 7 and minus 8 to the queue. Now I also pop 0. It's added to the sum, but it's still 7. Okay. Yeah, try to add left and right of 0. I try to add left and right of this node to the queue, but it's null on both left and right. So no need to put anything inside the queue. Okay, gotcha. So I see now I have compared all the nodes at the current level, and the sum comes out to be 7. So if I compare the sum to the maximum sum, that is 1 right now, I see that yes, the sum that's right now, that's 7, is greater than the maximum sum. So what I would do, I would just update the maximum sum to be 7 and update the maximum level to be 2, because I found the maximum sum, that is 7 right now, at the level 2. So also update that. Okay, and I would also be like keep on incrementing the level before like going in the for loop. So again, now I push like 7 and minus 8. Now I again do size. Now the size of the queue is again 2. So I run a loop for again 2. So I pop 7 first. Okay, now the sum again becomes 0 since I'm doing it for a fresh level. So I pop 7, I add 7 to it to add 7 to the sum. Now I check the left and right of 7. Oh, this node doesn't have a left and right, so no need to push anything inside the queue, so remove that. Now I pop minus 8 out of the queue. Now I add minus 8 to it, and this sum become minus 1. Does minus 8 has anything left and right to it? No, it doesn't. So simply pop minus 8 out of it, and no need to push anything inside the queue. So I compare the current sum. I see the current sum is minus 1 and the maximum sum that I have is 7. Is the current sum greater than the maximum sum? No, it isn't. So no need to update the maximum level. So no need to update the maximum level. So no need to update the maximum level. Yeah, so we would let the maximum level as it is because we didn't find a larger sum at level 3. Okay, so also we would be like keep on incrementing levels at every level count before every for loop, so we are able to know at which level we are at right now. Okay, now since the queue is empty right now, and we would break out of the loop and come out, we find that we have found the maximum sum to be 7, and that is present at level 2. So we would just return 2 as the answer. So this was the explanation of the code. Now let's look over the code part and let's see that how we have coded our solution. Okay, so first of all, as you can see, this is the question and this is the solution. So first of all, we have the base condition, right? So let's say we have a root, we don't have a root, and simply null. So that means that this tree doesn't have any level. So we would simply return 0. Now, as I told you, we are going to make queue of the tree node data structure that we are given to us, and let's name it nodes, and we push the root inside the nodes. Then we assign the variable, that is the maximum sum, maximum level, and level count. So maximum sum would be storing the maximum sum that we have encountered till now. The maximum level would be the level at which the maximum sum have been found. And level count is just that we are incrementing the count of the levels. So we are able to track at which level we are at right now. So we implement this while loop here. Where we take the initial size of the queue and then initialize a new variable called sum with 0. And we also do a level count plus plus to make sure that we are at a new level. Then we run a for loop for the size of the current queue. So all the nodes that are present in the current level are popped and summed, and the subsequent next level nodes are also pushed inside the queue. So first of all, we take a current node, we do nodes.front, and so we run that loop. We take the current node at the top of the queue, we pop it, we add it to the current sum variable. Then we check that, hey, whether this node has a left node, which it doesn't. If it has a left node, simply push inside the queue. If this node has a right node, simply push that as well inside the queue. And yeah, this is how the for loop works. And after we have took out all the nodes at a particular level from the queue and performed operations on them, at the end, then we're gonna compare the sum. We check if the sum is greater than the maximum sum. If the sum is greater than the maximum sum that we have been tracking right now, so we would make maximum sum to be sum and maximum level with a level count, because this is the level that we have encountered the maximum sum at. And finally, after the queue is empty, we come out of a while loop and return max level. So yeah, this was the problem of the day of 6th of January 2026. It wasn't that hard. It was like simply a very, very medium question. I would even tag it as an easy question if you have a good experience with trees. But yeah, it is. I hope you're able to understand the problem very well. It was my first solution on YouTube. Yeah, if you like the video, do like it. If you love watching the video and able to understand, then do like it, and do subscribe to my channels for like more videos. I'm planning to make like good quality problem of the day videos, and apart from that, contest solutions. And yeah, I hope you all have a great day ahead. Bye.